Okay, we're given that a company sells items of a product whose price follows this following price demand function, where quantity X is given as X, sometimes it's given as Q, so in this case we're using X. If the cost to manufacture the product is given by the function, and this is the cost function, so we have the price demand and we have the cost function, and the question is, what is the price of the product that maximizes the profit? We need to maximize the profit. That's P of X. The profit function is the revenue, remember, minus the cost. So the revenue, remember also, if you have the price demand function, then the revenue is just XPX or QPQ if you have it in function of Q. So this is X times 64 minus 10X given here. And so multiply it by X, so you get 64X minus 10X squared. This is the revenue function. So it's a parabola that opens down because the coefficient of X squared is negative. Okay, good to know that this is the case. So you have 64x minus 10x squared. That's just, I copied the revenue function from here. It was the revenue minus the cost. The cost function is given to us here. So minus, and then you have 25 plus 4x. So this means that the answer will be 64x minus 10x squared. I'm doing it slowly, minus 25, and then the minus will go inside because it goes to both of them, of course, minus 4x. And now 64x minus 4x is 60x minus 10x squared minus 25. So this here, which is also a parabola that opens down because the coefficient of x squared is negative. Good to know. And this is the profit function. Okay, great that we got the function first. Now we need to do what to it? We need to maximize it. Maximizing implies immediately you need to take the derivative. So this is to maximize it. Take the derivative, and now the derivative of this parabola is a line. It's just 60 minus 2 times 10 is 20x minus 25, the derivative is 0. So we don't have to write it. This here is the derivative. It's so simple. And if I set the derivative equal to 0, then this will mean that 60 minus 20x is 0. So 60 equal 20x. If you take it to the other side, and then divide by 20, so you'll have x equal 60 divided by 20, and this is 3. So when x is 3, you have a critical number. Therefore, we have one critical number for this function. One critical number at x equal 3. And we want to know if this is a local maximum or minimum. One way to do it is by looking at the sign of the derivative. So you'll say put x equal 3 here and check. The derivative is 60 minus 20 times x. So if you take something smaller than 3, let's say any number, 1, and you replace it in the derivative here, 60 minus 20 times 1, so it's a positive answer. If you take something more than 3, like 4, and you replace it in the same formula, you'll get 60 minus 20 times 4, 80. So 60 minus 80 is negative 20, so negative. This means that since this is the f prime, and at this point at 3, it's exactly 0. So the function f is going to be increasing if the derivative is positive and decreasing if the derivative is negative. This means that this point at 3 is a local maximum. This is one way of showing it. Once you know that you have a critical number at this point, it means a 0 of the derivative or a place where the derivative doesn't exist. And in this case, this is the first method, for example. The second one is compute f double prime of x. Where is, or p, in this case we call it p. Our function is p. So p prime, remember it was what? 60 minus 20x. So double prime, it will be 0, and then minus 20x, minus 20 is the derivative. So it's negative 20, so it's negative always. So the second derivative is always negative. This means that the function is always concave down. And if it's concave down at a point, it will be concave down at 3. So it means 3 must be a local maximum. If it was concave up at 3 like this, then this will make 3 immediately a local minimum. And in this case it will be the derivative will be negative here and positive there. If you want to know, that is the opposite case. You could have it with another function, but not with this one. And sometimes the sign might not change. Sometimes you can get plus and then plus. Notice, it could happen. There is one question with these review problems that has the sign not changing. And so maybe you can spot it now if you look at the other questions. So in this case, we got a maximum at x equal 3. So at x equal 3, we have a maximum for what? For the profit function. It becomes maximum when x, the quantity, equal 3. So put 3 back for the price, because they're asking you the price that will maximize the profit. So x equals 3 is the quantity that maximizes the profit. So let's put it back in the price equation and know how much the price should be to maximize the profit. So you'll say P of 3 equals 64 minus 10 times 3, which is 64 minus 30, which is 34. So maybe it's in dirhams. Yeah, let's say dirhams or dollars, depending on the question. So this is the price function. So 34 what? Dirhams, of course, per item, per one item. This is very important. Or some $34 per item. So this is telling you how much you should ask per item, not per 3 items or anything like that. They're telling you if you are selling 3 items, then the price of each one should be 34. Okay, this is very important to remember, that this is price function is per item, not just you give the price as dirhams. No, you have to say dirhams per one object. Just, or understand it at least in your head like this. Okay, so the price that would maximize the profit is when you say I want 34 dirhams per one of my product, whatever the product is. Here we didn't say what the product is, but think of any product that you could sell for 34 dirhams, and that would be your product for this question. Just, I'm leaving it to your imagination. Okay, but that's nice. Now let's just check our answer with Dismos so you see it really. So first, the price function is 64 minus 10x. It's a line, yeah? And in blue. Perfect. The cost function, here first we need the profit really. We don't need to graph the revenue or the cost. We need the profit function, which is here. Let's do it. 60 x minus 10x squared. Oh, I'm writing it in the wrong place. Sorry for this. So here, I need to write a new one. Yeah. So 60x minus 10x squared minus 25. I'm copying from here. Yeah. So is it the same? Let's check. 60x minus 10x squared minus 25. Perfect. Yes. And so let's see now if our answer makes sense or not. They asked us find the x that will make the profit maximum. The profit function is the green. Yeah. And look, 3 is the x that makes the profit maximum. And at that x, the profit is 30 dirhams, 65 dirhams. Yes, but they're asking what is the price when x is 3. Well, this is because this here, when you replace 3, it's in the profit function. But the question that we had was, what should be the price when x is 3? So we can graph x equal 3 to make it easier to view, and then just make it dotted like this. And here, 3 makes the profit function maximum, and when you replace it in the price demand function, which is the blue, you will get that the price per item should be 34. That's the 34 that you see here. Because the question was, if you look back, they said find the price that maximizes the profit. So the Prophet told you the thing that will maximize me is when x is 3. So what should the price be? You ask yourself, I know that x is 3. So what should I do? Yeah, put it in the price demand function. Put the 3 here. And so you'll get 64 minus 30, which is 34. So according to us, yes, the price should be 34. And here it's confirmed. The blue function, which is the price demand function, at x equal 3 is 34. And what is so special about x equal 3? It's the x that maximizes the profit. So how did we get it? By finding the derivative, setting it equal to 0, like we did in the question here. First you find the profit function as revenue minus cost. In revenue, always you get it from the price demand function by just multiplying it by x. You get the revenue, and then you do revenue minus cost here, and you'll get revenue minus cost, and you simplify it, you get a parabola. That is the profit function. Then find its maximum by taking the derivative, setting the derivative equal to 0. Then you get x equal 3 is a critical number. Then you do a test, either first derivative test or second derivative test. You get that it's a local maximum at x equal 3. And so you know that at x equal 3, our profit is maximum. So now you take this x equal 3 and plug it back in the price demand function, because they asked us to find the price. And when you replace 3 in the price demand function, instead of x, put 3, then this will be 10 times 3, so 64 minus 30, and so you get 34. And this 34 is the 34 that you see in the blue curve here, and the blue curve is the price demand function. So at 3 you have 34, and I will stop here.